Welcome back again to Cebu Electrical and Control System tutorial. At this video, we're gonna discuss about the vibration transmitter associated with electrical system. As you can see on the screen, I have already prepared here the complete circuits for the vibration transmitters associated with the electrical schematic diagrams. As you can see here, this is the motor, which this is the main purpose of this circuit to provide protection of this motor, which is this vibration transmitter. So here, aside from motor, there is a bearing. This is the bearing, and this is the axial vibration probe with this device, and this is the casing of the vibration probe. And here, this is the vibration cable, and this is the vibration transducer, and this is the GV or junction box or terminal block or TV, and this is the CMS module or conditioning monitoring system. And we have here range of the vibration transmitter and set trip set point. We have here the power diagram of the motor. This is the contactor. This is the power line 1, line 2, and line 3. And this is the control diagram of this motor. And this is the part of IPS or instrument protected system. And this is the electrical. So right here, I'm gonna discuss in one by one each of the electrical components. As our topic of this video is this protection of this motor, protection from the high vibration. And this motor, there is a rotor. This shafting is driven by the rotor of the motor. So in that shafting, they provided a bearing. And that bearing, there is vibration casing, this point. And we have our axial vibration transmitter. And then we have connected from the axial vibration probe, it is connected to the vibration transducer. And then the output of the vibration transducer is connected to the GV or junction box. And then from the junction box, it is connected to the CMS module. And we have here digital input from the CMS. And we have here digital output from CMS as well. And here, and then this the cable with probe. This is the original vibration probe. This is the one, which is this the one. This is the lock nut, and this is the lock nut. And this is the cable. So the proper adjustment of this vibration probe is to put your multimeter on this vibration transducer. Your multimeter leads positive, you just put on the common, and then the out, that is for the supply. This B, this is power this B and common, it is power supply of this vibration transducer. And this the out, this is the digital input from the vibration transducer sending to the CMS system. And then, and this is the R1. This the R1 is the part of the digital output of the CMS. And this one, this is the control diagram of the electrical, and this is the power diagram of the electrical. So here, the range of this vibration probe is 0 to 100 feet, and the set point high vibration is 70 feet. So here, the adjustment of this vibration probe, as you can see this probe, this is the lock nut, and when you open this lock nut, you can push it down or you can lift up the probe by this casing. So the adjustment, the proper adjustment of this vibration probe is, as I said earlier, that you have to put a multimeter on the vibration transducer, and then you have to adjust this vibration probe. So this is the top of the bearing, and this is the bottom of the vibration probe. Once you push closer to the bearing, the reading of the voltage is lesser. Then when you more gap between surface of this bearing and the bottom of the probe, then the voltage reading more. So to adjust, the proper adjustment of this vibration probe is 0 to 10 volts. When you adjusting this vibration probe until you will get the 10 volts, then you have to lock this lock nut so that will not move anymore this vibration probe during the running. Otherwise, it will be malfunction the this whole system of this vibration transmitter. So here, as I see this, the connection from here point goes to this vibration probe. This vibration transducer, it is mechanical to electrical energy conversion. The mechanical, the vibration, it will be converted to the electrical energy, which is in the electrical energy signal will be sending to CMS. So at this moment, at this condition, the running is, although the motor it's running because the digital output or the digital input signal from the CMS is closed, meaning the signal is closed. There is the vibration condition, it's healthy because it is reading here a digital input is closed. So once this digital input contact close, this R1 digital output will be energized. Once this R1 will be energized, then this auxiliary contact of R1 will be closed. So once this R1 normal contact will close, then the C1 will be energized. This IPS, this instrumented protection system. Once the CO1 energized, then the CO1 contact will be closed. Then the electrical contactor KO1 will be energized. And then the KO1 contactor is close contact, then run the motor. And then how the motor protected from the vibration? So as I said, this vibration probe range is 0 to 100 feet. The set point, the high set point will be tripped on 70 feet. Once the vibration raised on the more than 70 feet, this contact will be open. Once this contact will be open, this R1 will be de-energized. Once de-energized this R1, then this contact will be back to the normal. Will open and open, de-energize these two coils, and then open the contacts of the motor. And here, how it is protected by the vibration of this motor, because during the running of the motor, and this shafting is driven by the rotor of the motor. Once there will be an abnormality condition of this shafting because of the bearing or the rotor condition or whatever, then the vibration will be high. That's why this motor will be protected by the vibration probe, because once the high vibration, once the rotor or the shafting of this motor will be on high, then the temperature or winding will be high also. So there will be a tendency to damage the motor winding, because once there will be a high vibration, then it will be effect to the winding of high temperature until the winding will be burned. That's why this motor will be protected by the vibration probe. Once there will be a high vibration, it will be automatically trip the motor due to this contact, this digital input contact, then to de-energize this R1, to de-energize these two coils, and to open this contact of the motor. So once the contacts will be normalized back to the close, then restart up the motor. Okay, that's the comprehensive explanation of the vibration transmitter with electrical system